Hello everyone. Today we will discuss about damping. What is damping? So before we understand that, we need to understand a concept of free oscillations. You must have seen children swinging in on a swing in the children's park. So you know that when the children swing on this swing, right? So once we uh, apply some force, so it starts swinging this way, right? Backward, forward. But if you don't continue to apply the force, then what will happen? Slowly the amplitude becomes lesser and lesser, and finally the swing stops, right? So that means if you apply a force and then the oscillations are taking place on its own, then these oscillations are not under the effect of any other external force afterwards. So these are called as free oscillations, right? So free oscillations, right now I have not written this, the definition of damping. So this is actually damping. So every next step the amplitude is decreasing due to the decrease in the energy, and this loss of energy results in decrease in amplitude. This is called as damping. So I'll just mention it. Damping is gradual decrease in the amplitude of oscillation due to the presence of damping, or you can say dissipative. Dissipative means the energies, uh, the forces which result in loss of energy. So dissipative forces. In the presence of damping forces is called damping, right? Better to write dissipative forces, right? So this is called damping. Now we are talking about the free oscillations. The natural oscillations of a body independent of any external force, right? So in case there are no dissipative forces, in case there is no loss of energy, what will happen? The oscillations will not stop ever, and that way if we imagine that situation, the child will continue to swing with the same amplitude forever ever. But that is not possible due to the presence of the dissipative forces. So if I want to draw the variation of the amplitude with time, displacement with time for undamped oscillation, what will be the form? Same amplitude every time for no dissipative forces, no loss of energy. But in case of loss of energy, what will be the figure? So this is loss of energy, therefore damped oscillations, right? And these are free oscillations with no loss of energy, right? So in case we continue to apply force to this swing, then what will happen? The child will continue to swing with the same amplitude. So what we are doing, we are applying force to continue the oscillations to overcome the dissipative forces. So these are called forced oscillations, right? So forced oscillations, the oscillations under the effect of applied force, right? So like this. So here continuous force is applied. So this way it will continue like this. So these are forced oscillations. And what is resonance? So what is happening is, when the frequency of the applied force is equal to the natural frequency of the body vibrates with the maximum amplitude. This is called as resonance. This is called resonance, right? So we understand this by taking an example of the behavioral science. See, when you people reach your 11th standard, the teachers are new, the syllabus is new. So sometimes initially what happens is that when the teacher enters the class, teacher has her own frequency of teaching and the students have their own frequency of learning. So teacher tries to apply her frequency to the students. So those are the forced vibrations. But in case the way of learning, the frequency of the learning of the students and the frequency of the learning of the teacher, right? If these match naturally, then the learning or the output is maximum, right? So this is to understand, not technically. So here, whenever the natural frequency of like you students matches with the frequency of the teacher, like matches with the frequency of the applied force, then the amplitude is maximum. In behavioral science, the result is maximum, right? So this is called as resonance, where the amplitude is maximum when the natural frequency of the body is equal to the frequency of the applied force. So this is resonance. So this was all about this topic. So that's all for now. Have a nice day.